Hey guys, it's me again. I'm gonna show you guys how to actually solve the problem that a lot of you guys posted on for this discussion. Actually, everyone should have posted on for this discussion if you're already at this video. By the way, you guys did a great job from what I've read so far, kind of trying to figure out how it is that you would actually solve this problem. So before, I would just give you like an angle, you know, it was a right triangle already, and then either just like an X and then a side that you already knew, right? So what you had and what you knew, what you had and what you didn't know. So I'm going to show you guys how to actually work this out. I'm going to see if I can zoom in here a little bit. Beautiful. There it is. Okay, so what I want you guys to do is to, first of all, let's break this down. We're going to go ahead and solve for each one of these individually. So we're going to start by solving for x. Okay, so I want to go ahead and solve for x. Okay, and again, you guys know how to solve for x. We know how to solve for x because, you know, we're going to use the same thing the way we normally did. So forget about this y right here, forget about the z. Now this looks like one of those problems that you guys had before. So forgetting about this, you guys know how to solve these at this point. Okay, so again, this is the angle that I have, that would be my theta. Right across from here is my opposite, right? You know that this would be your hypotenuse because the hypotenuse is always across a 90-degree angle, and this would be your adjacent. Okay, now again, I'm trying to solve for x, so something that I have and something that I need. So I have the opposite and I need the x. That's what I want. So opposite and hypotenuse. Remember what's opposite over hypotenuse? Yep, that's SOH, the SOHCAHTOA part, right? SOH, sine of theta. You know your theta is actually 48 degrees, is equal to opposite over your hypotenuse. Okay, 17 over x. Okay, so again, what are we going to do? You're going to go ahead and actually multiply by x, right? Because you want to make sure eventually that we have x by itself. Now we are left with x times sine of 48 degrees is equal to, you know, that's going to cancel, so you're left with 17. And then again, what are we trying to solve for? We're trying to solve for x. So we're going to go ahead and divide this guy out by sine of 48 degrees on this side, sine of 48 degrees on this side. When I do that, you know that this is going to divide out. We're going to be left with x equals 17 sine of 48 degrees. Okay, now, obviously, that's not a real value. We have to go ahead and punch that into a calculator. I'm using my scientific calculator that I'm using from Google. So let me go ahead and punch this in again. Again, it is 17 divided by sine of 48 degrees. So I'm going to go ahead and punch in 17. Remember, it has to be in degree mode. If it's not on degree mode, that's not what I want. I don't want radians, I want degrees because we're talking about degrees right now. So I have 17 divided by, I like to put this in parentheses, sine of 48 degrees. Okay? And that's going to give me 22.87. Now, remember, we are rounding off to the nearest hundredth, right? To this value right here. So I'm going to look at this one to the right. If it's greater than 5 or greater, then this one goes up 1. If it's 4 or less, it's going to stay the same. Okay, so that's that. It's greater than, it's 5 or greater, so that's going to be 8. Becomes an 8. So this is 22.88. That's my final answer for x. Okay, so I'm going to cut off this video here. That's how you solve for x. You guys should have already known that maybe. But I'm going to go ahead and now solve for y in the next video, and maybe z I could probably squeeze that one in. All right, bye.